Hello everyone, welcome to this session. In the past few sessions, we have already discussed the way of training of neural network models. And one thing that can't be avoided is underfitting and overfitting. So in fact, we have already introduced this concept in the second week of this course, right? Of this specialization. So now we first review that. So as we can see in this figure, we can see for classification, for regression. So the right fitting is in the middle. So we can see that while it's right fitting, the input and output, right, the tendency or general trend or the underlying relationship between them are caught by the machine learning model. But for overfitting, we can see it here. We can see the machine learning model, we catch the small details of the input and output in the training set, right? And that is not what we want. And for underfitting, that the model fails to capture the underlying relationships between the input and output in the training set. So we want to avoid the both overfitting and underfitting. So to avoid it, we first know that it happens. So how to observe that? We can see the following table, right? So if the fitting is good, we can see the loss from the training set and the test set, both of them should be small, right? And when it's overfitted, we will find a good result in the training set, but a bad result in the test set, because such models doesn't have the good generalization ability, right? So the test set should have high loss, training set should have low loss. And for underfitting, it's easy to see that both training set and test set, both of them have high loss. So here I provide a brief review of the underfitting and overfitting. So now we want to avoid underfitting and overfitting. So we first need to analyze what are the reasons of them, and then what are the solutions. So let's start from the underfitting. So for underfitting, the reason can come from the data itself and from the training process. So let's see from the data itself. The first reason is that the training data has limited diversity. This means that the training data can't represent the whole data set, right? So the method to avoid this is to work more on the data acquisition. We should gather more data that can reflect the larger population. And the second reason is we call it the feature scarcity and irrelevance. So in this way, there are many irrelevant features. So for example, those are the noise. So those can come in to make the machine learning model quality becomes low. So in this case, we can do more on the data preprocessing. So for example, we do the feature selection. So select the useful features and important features that we need to use to train the model. So besides data, we also have reasons considering the training. So for example, the inappropriate hyperparameter setting. So this one causes both underfitting and overfitting. So this means that hyperparameters in the neural network model is inappropriate. So in this way, we can tune, for example, the learning rate, the activation function, and the batch size, so such as these ones, right? We need to tune the hyperparameters to make the model work better. Another commonly seen reason is that the lack of training iterations. This means the training stops too early, so before the loss function converges and the training stops. So the model is halfway. So in this way, we need to spend more time on the training until the loss function converges. Another quite widely seen reason is the model is of insufficient complexity. So for example, a data relation between the input and output is complex. The relation is complex, but the model is too simple. So the model is not complex enough to represent this relationship. So in this way, we should make the neural network model become more complex. So we can add more layers or we add more neurons to the neural network. Now we can see the overfitting, the reasons and the solutions. Again, the reasons come from the data itself and the training process. So let's see from the data itself first. So first, we can have the insufficient training samples. So small training data, but complex model. This always causes overfitting. So in this way, we need to gather more samples, right? So this can somehow remove the overfitting. Also, some of the data are imbalanced. So for example, in classification, the proportion of the classes are skewed, right? So in this case, we need to apply the weighted decision making on this data. So I think you still remember the stratification, right? Yeah. Also, another possible reason is we call it data leakage. So what is data leakage? So ideally, the training data and the test data, they should be completely independent with each other. But in some cases, they are not. So in this case, when we observe data leakage, we need to make sure the samples from the test set are not really involved in the training. So sometimes this is not obvious. So we need to dig more on this and to find it out and to improve it. So these are the reasons from data itself. And also we can see the reasons from the training. So also inappropriate hyperparameters also cause overfitting. It can cause underfitting. It can also cause overfitting. So in this case, we need to fine-tune the model hyperparameters. Another reason is that the neural network model is lack of regularization. So what is regularization? So we will discuss it in the next sessions, right? We will just apply the regularization to the training, so it will be benefit to avoid overfitting. Last reason is that the model could have excessive model complexity. So the model is too complex, so this sometimes causes overfitting. So in this case, we need to reduce the layers or the neurons to make the neural network simpler. Right? So this can also help to avoid overfitting. So this is just the above is just a brief introduction about the underfitting and overfitting. What are their reasons and the solutions? And also there are other reasons that are not covered here. So more details will be in the advanced course, the advanced specialization. So not in this introductory specialization, but in the next one, right? Advanced techniques. So we will have a separate week to introduce how to tune neural networks. Okay, thanks for listening. Bye-bye.